Cool, we'll go ahead and get started. How's it going, everybody? Thanks for joining. This is the latest in our Scanner Spotlight series at Digitize Designs. I'm Patrick, our head engineer here at Digitize. So if you don't know a little bit about us, we're a 3D scanning solutions provider. So that comes in the form of providing the scanning equipment or doing scanning services. And whether that's data acquisition or manipulating that scan data afterwards, or coming on site or giving you guys the ability to do that, setting you up with the hardware and the software you need to solve problems with this 3D scanning hardware and software. Today we're going to focus on the Artec Point. So that is this guy. Get a little closer to this top camera up here so you can see that. So this guy's pretty cool. It's the first metrology grade scanner that Artec has carried. It is accurate to 20 microns, a little bit better than a thousandth of an inch if you are used to talking and thinking in inches. So it's a little about 10 thousandths of an inch. It's got a volumetric error stack up. So anything basically you could fit on like this turntable, for example, you're going to get about that 20 micron accuracy. Anything larger, there's a little bit of stack up that you gain per meter, but it's significantly less error stack up than something like the Leo, which is the most accurate large thing scanner that Artec's carried previously. So also, before I get too deep into anything, the webinar's question and answer form, if you have anything, anytime, feel free to drop it in there. I'll try to keep an eye on that, and we'll definitely have some dedicated Q&A time at the end. But the rest of the agenda for this, I'm going to show you a little bit about how the point works. I've got a handful of things here. I'll talk about like useful applications for it. If anybody has anything in particular they'd like to see, I might be able to pull something off the shelf. Feel free to drop a question in the live Q&A, and I'll see if I can accommodate. So yeah, the point hardware-wise is pretty simple. It's pretty compact. In fact, the case and everything is here. I've got the calibration board out. I'll show you how that works. But everything you need to scan is in the case here. The hardware by itself is pretty simple. There's a few buttons on the back. There's these 4 play, pause, plus, minus. Get that in the center of the camera there. And M. So play, pause is going to start and stop scanning. These plus and minus and M are going to let me change some settings while I'm scanning, or tell Artec Studio what I want to do, the scanning software, Artec Studio, when it's about to start scanning. The business end of everything here are these cameras and laser emitters. So these two guys are cameras surrounded by LED rings. And then there's 4 laser emitters in the middle. And the 2 cameras are basically little eyeballs. They're going to watch for a couple of things. First things, they're going to look for targets, like you can see on the turntable here. I've got some on my part. I've got some around the part. For larger parts like this, you typically do want a few on the part. For smaller things, you can do just turntable targets. Like we'll do this little guy in a minute with just the targets on the turntable itself. So these 2 cameras are watching for those targets, and they can, as long as they can see 4 in the field of view of this, which field of view is about a little bit bigger than this calibration board is, depending on how far away you are from something. So as long as there's 4 targets in the field of view, it knows where the scanner is in 3D space. And then it's also going to project lasers from these laser emitters onto the object. And then based on how those bend and deform, that's how it's able to really accurately capture points that are along those laser lines and stream them over to the scanning software. And they'll collect there as a point cloud, visualizing the object. And then once you've got 1 or more scans, you can combine them together if you like, and mesh them into one STL, really accurate STL of whatever you've got in your field to be scanned. Last hardware thing, I've got the cables. I've got power and USB. It's 1 cable with 2 ends on this end. Other end, one side plugs into AC power. One side plugs into the USB on your laptop. This all together works with the Artec's existing scanning software, Artec Studio. So if you're familiar with this, if you've used something like a Leo or a Space Spider or an EVA, any of the other Artec scanners, you're already familiar with the software that you need to use the point. The interface is a little different just because this is a target-based scanner that works a little differently than the Spider or the previous ones did. But you're already, all the post-processing stuff will be really familiar to you. Cool. Let's go ahead and I've got Artec Studio open. I'm going to come in here and tell it I'm ready to use the point. I've got a really simple little scanning interface here. Just got to pick a resolution. Um, and basically, resolution is how closely together it's going to space all the points that it's using to evaluate to resolve your object in space. So I can go anywhere as low as 0.05, technically as low as 0.02, all the way up to something like 1 millimeter or higher. So 1 millimeter is a pretty good, really quick scan with less detail. And something that's interesting about resolution, it's typically conflated with accuracy, but they are separate concepts. Resolution is just level of detail. So as I decrease this number, my points get closer together. I have to scan a lot more points to scan the same surface area of something, but I can capture smaller and smaller details the lower that resolution goes. I'm still going to get the just as accurately spec as the scanner specified, so the 20 micron each individual point accuracy, regardless of the resolution that I'm at. Just you'll see things like on these little circuit board, for example, there's some stuff on here that if I scan this at a millimeter resolution, they're just not going to show up, or they're going to be very hidden kind of away. There's just things smaller than a millimeter, the points could just skip over top of it and you won't see that thing. But if you crank that resolution up, you can capture that fine detail. So we'll do something like a half a millimeter for this transmission housing here. Got scan targets and geometry, refine geometry, and calibrate. We'll start out by calibrating. You don't have to do this super often. It's advised about once a day, depending on if you're reaching maximum accuracy or you need to reach maximum accuracy. It's advised to let the scanner warm up for about 20 minutes and then calibrate it before you use it. But it's really easy to do every day. Calibration board lives in the case underneath here. You just open it up and you can leave it sitting on its own here, or you can pick it up once you've gotten used to it a little bit. But then you just hit the calibrate button in Studio. Oh, let me show my screen also. There we go. Fix my video. There it is. It was mirrored. So you follow the instructions on the screen. It wants you to hold the scanner right above that calibration board and turn those lasers on with the play pause button. And then lower it up and down until the scanner pops up. And then it's showing you a real live 3D readout of where the scanner is. You just have to line it up with the one that's showing you on the screen and run it through a few different positions. Most of them are just in a straight line, these first 10. So it's super easy. You just pick the scanner straight up away from the board, and then there's 4 directions: left, right, up and down. Not in that order. Right, left, down, up, I believe. Once you complete this last one, everything's finished and scanner's calibrated and good to go. Cool. So let's get started with this part here. This is just a little transmission housing. If you've seen one of our other webinars, you may have seen us use this example part before. It's just got a lot of good little fine detail and mechanical stuff on it. Pretty representative of what we see a lot of our customers are looking to measure: holes and crevices and grooves and things like that all over it. So we'll choose a resolution of half a millimeter, and I'm going to say remove base, and I'll explain what that does. There's my screen, sorry. And so we picked our resolution here. We grabbed remove base, and I'm going to start by just scanning targets. So you'll notice a lot of my targets are on the turntable surface itself. And what that's going to allow me to do is set up a background plane. Well, Artec Studio actually does it for me automatically. It'll try to identify a flat surface that has lots of targets on it. And we'll see the step happen here in a moment. It'll automatically fit that plane in there, and it'll keep me from scanning the table. That's what that base removal checkbox I checked does. So I'm just moving around the object. It's going to pick up those targets. You can kind of see the the target showing up in Artec Studio up there in the corner. And I have way more targets than I need. You can kind of see at any given point, it'll show you which ones it's using, and it's probably got 13 or 14 in each field of view, and it only needs 4 in any of those places to be able to scan. So I just want to do a couple revolutions of this turntable and spin around and capture all those targets so they're ready for me to use. Once I'm finished, I'll skip to the next step by pressing one of the buttons on the scanner itself. It brings me back to the screen. Next step is going to be that scan geometry button. I can either click in the screen or I can click one of these buttons here on the scanner. So I'll tap that button. Artec Studio will get ready for scanning that geometry. That orange plane that you just see, it identified the floor, and it says it's going to exclude that from my scan. So I don't have to worry about cleaning that up myself later. It's ready for me, so I can click the play pause button and start collecting data. So I'll stay still for just a second so you can see those laser lines in Artec Studio, and the left side of the screen has a distance meter that's showing me how far away I am from the object. And really what I'm going to do here is basically paint with scan data. See if I can switch this around a little bit so you can kind of see the screen while I'm scanning here. Anywhere those lasers hit, as long as I've got targets also, I can use these lasers to fill in data. You can kind of see the object already resolving pretty quickly in front of me. And the process is super visual. Anything that I can see shows up on the screen, I've got captured. Your first pass over something, sometimes it kind of, if you don't go the right speed, it'll look kind of hairy over there. Like, let's see, zoom out a little bit. You can see that area that I passed over quickly. That's super normal. Every little nook and cranny has to get hit a few different times by these lasers, but they're capturing data super, super fast. So the way to solve that is to just pass over them again, or instead of moving super fast, slow down just a little bit. Still, you can probably move pretty quickly depending on what resolution that you're at. But everything fills in pretty easily. Got a few different laser modes at your disposal. So this first one is laser crosses, your default largest scanning area, quickest speed. You've also got fine, hyperfine mode with these parallel lasers where I do have to get a little closer to the object. And usually that means you need a few more targets if you have them spaced out really far. But this mode is really well suited for capturing like high resolution data and dealing with certain like difficult to scan surface finishes like dark or shiny. Yeah, there's one laser mode that's available to you. Lastly, you've got single laser. So I'll double tap again to switch to that one. So this one's really good at getting maximum depth inside of holes or nooks or crannies. But it is the least speedy of the 3 modes because of that. It's kind of for coming in at the end and trying to fill in any holes you wanted to get maximum depth in. So switch back through, cycle back to the crosses, and we'll fill in everything else. The inside here, I'll try to go a little quicker and talk a little less so you can get an idea for how long something like this might take. Once I'm finished scanning, which again is just super visual process. If you see a hole that you need to fill in, you might want to go back and fill that in. You can zoom in and get a better idea of what you've got in a certain area. I find it's really nice to get into somewhere really close. You can lock the camera position. And there we go, lock that camera position, and then you can move the scanner around and you're still locked in on that area that you're looking at. If I was like looking at this hole, for example, get a little better idea of what I've got or don't have in there. Once I'm finished, I can end a scan. It's going to do some thinking here, basically doing some noise filtering and reconstructing that point cloud over here. While we're doing that, I'm going to pull up my CAD file. So the first thing we'll do with this is run a real quick inspection on it. So we've got some dimensions that we'd want to measure, or just we wanted to compare this to a CAD model and get an idea of how well it fits the original part that we created. We can do that. I've got a CAD model of this little part ready to go here. And we're going to be using, I think I might have mentioned it already, sorry, Control X. It's going to be the software they're going to look at for inspection. There's a variety. This scan data will work with any of your major inspection softwares, Polyworks, Control X, Verisurf. There's a big handful of them. But yeah, Control X is what we'll be taking a look at today. So I've got Studio just finalizing that scan for me. It's just fusing it. If we zoom in super close, you can kind of see all the individual points that the scan was made of. Artec Studio renders them as little hexagons. And I'm running a fusion on them. That's just going to, instead of a point cloud, we typically want a mesh, an actual surface, instead of a bunch of like thousands of discrete points. And there's that, as soon as that fusion finished, you saw it pop in there in green. That is just a surface representation of the object. If we look at the individual, turn on the edges, you can see the individual triangles here. So it's truly a surface instead of individual points. Looks like it's about 5 million triangles in this whole model. But there's everything that we captured. If we zoom back in really close, you can kind of see all those triangles really evenly distributed. And this is another way to visualize that resolution that we chose earlier, is that 0.5 millimeter. That's effectively how large all these triangle edges are. So you can imagine if you go, those get smaller, triangles get smaller, and they can wrap over smaller and smaller details. They get bigger, they'll smooth out smaller details a little bit more. A first step we typically will do once we've made a mesh is just run it through this mesh optimization and have it simplify down the number of triangles a little bit. So it's going to do that intelligently. It's going to leave the more triangles in tighter areas where there's fine details or large, like small curvature, and it's going to put larger triangles where there's flatter areas. So here's, you can see it here. There's the original, just the original with all those tiny triangles, and the simplified version. Notice on that edge, all the small triangles are still there. And on the top and the bottom, those flat surfaces, it made larger triangles. And if you turn off the edges, effectively that means you really can't tell the difference between those two without looking at the individual triangles. But this one is a quarter of the file size and the number of triangles involved. Let's actually flip this guy over. And we only have a scan of just the side we had facing up here. So if you see, we flip this over, you kind of see we're missing anything from the bottom. And so a really common workflow is to scan a part like this on two sides to combine them together. And to do that, we'll just hit New Scan, Scan with Artec Point. For this, we're going to pick the same resolution. It's just, it's important to have, if you're going to combine two scans, make sure they were scanned at the same resolution. And then we'll hit a new target scan. So ordinarily, if you were doing multiple scans in Artec Studio, you'd want to make sure the scans overlapped with the common geometry. That's naturally going to happen because of this whole outside. I'm going to scan twice, basically. And if you wanted to combine them without any targets, that's what you've got to do. You've got to have some common geometry overlapping between the two to be able to get them together well. In this case, since I've got targets on the outside, I have way more than I need. But if you have 6 targets that are visible in both scans, you can get basically a free alignment comes out of that. Instead of having to pick common points like you've seen if you're familiar with how Artec does alignments, currently you can just click use targets and it'll snap the 2 scans together for you automatically. And so we can do both here. We still have that remove base on, so you can see the There's that plane that's going to chop off the table for me. It's really easy to clean stuff out too. We didn't have to on this one, but I can show you what that looks like. There's really robust eraser tools and cut off planes and things like that in Artec we can use to Artec Studio we can use to clean stuff up. So this turntable is what I see is the most common use of the Artec Point. For especially anything that'll fit on a turntable, it's really convenient to have, so I can uh, spin the turntable instead of walking around this thing. But you certainly can use it like that if it's easier, or if it's something stationary. You know, you need to do some scanning on a machine uh, out in the plant, or on a vehicle or something that you can't get that piece off of there. You don't want to. You can take the point to it, throw some targets on there, and scan that way. And these targets come with the scanner. There's two tins in the case of these adhesive. They're 6 mm diameter retroreflective targets, and you can do all kinds of cool stuff to make it a little easier to like go out in the field and scan. We've got a lot of little gadgets we've collected over the years, little dice, basically like 12-sided dice with targets on them and a magnet on the bottom to be able to just stick on something really quickly. We've got a target net. It's a big, there's two versions. There's a steel, like paperclip thickness wire mesh with targets at the intersection of each of those wires. There's a mesh, like actual cloth, like shoelace material almost net. You can drape over something really quickly if you want to scan it easily. All kinds of ways. I know a lot of people that haven't used targets are a little apprehensive about it sometimes. But there's definitely there's an extra step involved compared to like the Leo or something where you don't have to use targets. It is one extra step before you can start scanning, but oftentimes I find it saves you headache or time later, or it's just the fact that it guarantees the like registration. It kind of takes some of the post processing away, so it pays for itself later in time. For whether it's the automatic alignment between the two scans, or it's a very objective way of making sure your scans are accurate. If you don't have enough geometry and texture features with something like the Leo, you've got to know, and you won't notice that until you process it sometimes, until you get into Artec Studio. But with target-based scanners, you either have enough targets or you don't. If this doesn't have enough target information for tracking, it's not going to collect any kind of bad data. It's just going to pause scanning for a moment and then pick back up. And you can, if you find you don't have enough targets in some spot, you can, you don't have to start completely over. You can add targets in while you're going, and it'll continue to pick them up and keep going. So here we go. I've got these two scans now, and I'm just going to grab each one. Grab my eraser, and the thing I've got to do here to make the targets alignment work well is, since I'm using a turntable, is I've got to delete the turntable targets out of at least one of these two, or it might use those for the alignment. So I just selected what I wanted to keep with my paintbrush selection there, and then we got rid of those, or inverted that selection, and then deleted everything else. So show you that one more time. We'll do it to the scan too, though I don't have to. I grabbed my paintbrush and selected what I wanted to keep. I can also turn this to the side. You can kind of see the targets are there. I don't have to turn it to the side like this, but this makes it really easy to just zip the table out of it really quickly using the lasso. And just select all those targets on the table really quickly. I'm clipping a little bit of the part away, but I know I got that really well on the other side. So I'm not worried about that. So now we've got those two. We can align these. I've got my align tool. One scan turns blue, one scan turns gray. In this case, there's a couple steps we can do if we're not using targets, but I can just hit align and they auto snap together since I have targets in common. What that would look like if you didn't have targets in common is got the blue scan and the gray scan, and then I can manipulate the camera to move both of them around, or if I hold shift, I can manipulate just the gray one. And then that lets me orient this in such a way I can tell I'm looking at the same part of both. And then I've just got to pick a couple of common points between both scans. Select the tip of that 2 on the blue one. Nope. I have to turn targets mode off first. Click on the 2, spin this around and find, let's see, the intersection of those 2 ribs. You can always move stuff around while we're working too to make it easier to see. We'll do like the tip of that rib right there. And then those 3 markers are going to snap together to give me initial alignment. And it happened really quickly, but that initial alignment happens. It doesn't have to be super close at all. And then Artec Studio takes over, uses that common geometry between the 2 scans and finalizes that alignment and snaps the 2 scans together. So last step 2, we ran the fusion to turn them into a mesh. We did that on just the 1 scan. If you're going to combine 2 together, typically you'll wait until the 2 are aligned like this and then do that with both of them together. So run that fusion one more time. And then that's what we'll bring over into Control X to do some measurement stuff with. Cool. I'll switch to, looks like we're about halfway through. We'll do a couple of quick measurements on this, and I'll switch to one of these smaller parts, just to kind of show you a little more of what the scanner can do. Something cool about this type of scanner in general, blue laser based like laser scanners, they're really robust against different surface finishes. So that's something. The rest of Artec's lineup is full of like structured light scanners, which are awesome. They're good at capturing really good resolution, but they sometimes can struggle with things that are really dark or shiny or translucent. Those are like the trifecta of things that are difficult to scan. And but lasers are different. They're a little bit they're a lot more robust against that. So things that are shiny or dark, there's settings to adjust. There's an exposure setting, a checkbox to scan that my object is dark and shiny, and Artec Studio will adjust scanner settings, and you'll be able to handle most of those things. The only thing I've ever seen we've had to apply spray for with laser scanners is anything that's truly translucent, like or completely transparent, like glass, really clean, smooth plexiglass or something like that. Then you do typically have to throw something on there if you need to pick that up. If you're scanning a car, for example, and you need to get the windshield, you either got to throw a piece of painter's tape or some spray on there to get that to pick up. But then the last, I won't show you exactly all the processing involved in this, but one cool bonus of the Point is that you can capture color with it, with Studio and technically other hardware. You need either an iPhone or a digital camera, some way of capturing color photos. And you can combine those color photos with the really awesome geometry that you're going to capture with the Point using only Artec Studio. It's been something, it's technically possible with like free software, taking a 3D scan that has just geometry, taking just photos and doing a process called photogrammetry, taking a bunch of photos around an object and capturing it that way and combining them together. But it's very complicated and uses a bunch of different softwares. But since both of those processes are available in Artec Studio, you can do it all here. You scan the object, take a bunch of photos or one video of it actually scanned from, like, basically take a video and you do a couple loops around it, hit it from a few different angles. And then you can make those both into meshes, combine them together, and basically colorize the really cool geometry, really precise geometry that you're going to get with the Point using those photographs. And I've got an example of that. We won't run through the whole process because photogrammetry takes, it's not crazy long, but longer to process than I'd want you to have to sit and watch me do on this webinar. But I've got a kind of pre-done project I'll share at the end of this guy. And then the reason I also thought of this is it's got a lot of shiny and translucent stuff on it. And I'll show you the Artec Point scan that I did of that. And we can scan it a little too, if we've got time. So my fusion finished. So we've got that guy. I'm going to run that mesh optimization one more time just to get the triangles down a little bit. And then we'll drop that into Control X. So waiting in Control X, I have a CAD model and tons of options of things I can do to align it or to measure things. So first thing I'm going to do is just hit export and export meshes. I can hit export to Control X and actually automatically send it over there to work with, but I believe that's going to open a new window. And I'll just save this off to the desktop here and import it that way. And yes, if you saw the folder, my last thing I saved in Artec Studio did say chicken surfacing. I auto surfaced a piece of chicken for as an example for a customer the other day. It's not the strangest. It was raw chicken. We've done a fried chicken scan before. Somebody brought some like Bojangles. It's for an advertising company that needed some 3D reference of some uh, fried chicken, and we scanned a piece of fried chicken for them. So we're in Control X now. I just imported that STL that we saved off to the desktop. So I've got what my part is ideally with everything being super perfect. The CAD model represents that. I've got the part as it really is captured by the point over here in blue. First thing you'll notice is they're not aligned. It's common with handheld scanners. They just they establish a coordinate system when you start scanning targets with them, but that coordinate system is based on wherever you started scanning. It's actually where that origin is. So you can see that's I had it oriented this way, and that z-axis is that's the very first position I started scanning with, and uh, that means it's not aligned to the CAD model. That's really easy to fix. You just run through an initial alignment, and if the thing's not super symmetrical, they're super otherwise. Uh, Control X can do a really great job of making that auto alignment happen. If it is symmetrical, sometimes you have to go through a 3-point process, like you saw me do with uh, the aligning the two scans together in Studio. And let me back up a little bit. If you're not familiar with what Control X is, it's inspection software. Let me get my front camera on here. Yeah, it's inspection software. And so what it does is it's really good at taking the CAD models and scans and automatically measuring things using them. Whether that's doing a comparison of the entire object, getting a heat map, which we'll see here, of how well that scan fits the CAD model, or actually extracting specific dimensions, GD&T callouts, anything you can think of. It's capable of all of that. So first step's always aligning. Next, if you wanted to do a datum alignment, align to specific planes or holes or anything like that, you have that option. If you want to grab a specific measurement, you just got to go grab the 3D dimension tool. And so grabbing two hole positions is as simple as just clicking those two cylinders or circles and clicking in space. Something I think is unique about Control X compared to other inspection softwares is how simple that is. In some things, you have to create both the circles independently, and then the dimension is a third object. So it's lots of button clicks just to get to that. Whereas you see what I've done here is, or everything you saw me do there is evaluated that measurement for me. It knew based on where those CAD edges that I clicked on, it knows where that circle is supposed to be from the CAD. It can automatically find out where it really is on the scan. It does that for both of those circles, and then it measures between their center points. And that number you're seeing there is the actual measurement. You can go into the details and see there's my actual and there's my reference measurement. And it's got a default tolerance on here, and that's why it's showing me green, because it's within that default tolerance. So things that are really quick to just grab a couple of quick measurements. You can, if you're doing this for like a one-off, you just need to check a few things. You can set a part up like that and check a couple measurements. If you're doing something where you're going to be doing lots and lots of these, you can set up as many measurements as you'd want. Pretty much anything you could define on a CAD drawing, you can define in Control X. And then once you've set that up one time, you can save this off as a Control X project. And all you have to do to measure another instance of this part is bring another part over here, scan it, and drop it into there. And then you can do a whole PDF report out of everything that you defined there. So once you've got that set up once, scan it, drop it in, save off a PDF of all the measurements evaluated from this part, bring another part over, scan it, do the same thing, new PDF, without having to click all the buttons to set all the measurements up again. If you just want a quick overall without having to set up individual dimensions, but just, hey, I think there's something wrong with this part, I don't think it's shaped exactly like it should be, you can do a 3D compare. It's what Control X calls it. This is you'll hear it called a heat map or a deviation map. This will just color map everything based on how well these two things fit together. So anything, currently my color map's set to a maximum of plus or minus 1 millimeter, and then a intolerance color of a millimeter, sorry, 0.1 millimeters plus or minus. So anything green fits within 0.1 millimeters. It's easy to just drag that around to adjust it. This is like a mostly cast part, so I don't expect a lot to be within tighter, much tighter than 0.1. Let's say there's a quarter millimeter. We can go even further out on the wider one too. And then anything green fits within that quarter millimeter. Anything blue is a little low. It's not got enough material there. Anything red or orange is on the high side, so it's got extra material there. And anything like gray, for example, that notch is missing from the CAD model. It's in my object. It's because it's further away than 3 millimeters. That's why it's gray here. You can come and see individual or call out specific points. If you wanted to see exactly where, how far off something is, you can click and get a call out for exactly that spot. Usually this is for like high spots or low spots to call stuff out that way. And again, anything you set up here can get automatically dropped into your report that you make and save off automatically. So we'll save this to the desktop real quick, and then we'll bounce back over to Artec Studio. Knowing that the scanner is as accurate as it is, it's also a really great tool for like reverse engineering and that sort of thing. If you are ever in need of one that can do both, this is a great option for something. Anything, if all of your parts would fit on a turntable like this, this is a no-brainer option for inspection and reverse engineering of parts this size. If you need to go much larger, it's capable of it, but needing targets, if you need to go larger than this often, I'd suggest looking at something like a tracker-based scanner or like a Leo, depending on what accuracy that you need. But this is perfect for small parts. And again, yeah, it can go larger. I've scanned too many large boats and cars and vehicles and stuff with a scanner this size and way too many targets. But if you need to do that once in a while, it can be it's very good. It just takes a little bit, and targets really don't take that long to put on once you get in the groove for something that big. Cool. Let's do. So thought this was a cool example. I was like really chunky threads are always an interesting thing to scan. Actually, don't know what this is from, but it's a really solid steel, very cool part, I think. So, and target scanning doesn't have to take very long at all. Switch my screen around. You just got to pick those targets up, really, is the important thing. In this scan, we got base removal on, and that'll automatically set that up. It's going to be really quick here. I did do a little higher resolution for this one, so it's going to scan seemingly a little slower, but it's just the fact that it's still scanning very quickly, but it's just having to grab so many points for this because those points are that much closer together. If you cut the resolution in half, you need 4 times the points to be able to scan the same area, since there's that like length to distance relationship there, or length to area. There's a squared in that formula. Until I get below 0.1 millimeters, I have the option of all 3 of my scanning modes. If you go below 0.1 millimeter resolution, you do have to use that parallel lasers mode. But typically you're only doing that if your part's very, very, very small. We won't do too much of this thing just because this fine resolution does take a second, but not too bad. While we're here too, I'll throw this little circuit board over here, show you some of that too. Again, this is getting closer to the highest resolutions that this scanner is capable of, but we're still not there. If there's stuff on this that doesn't resolve, we've got 2 ways of handling that. We can start a new scan, crank the resolution up even more. We've even got refined scan, which is if you have just one area you need to crank the resolution up in, but you don't want to have to scan the whole thing again. You can do that in a specific spot and basically lasso select what you want to replace and double or quadruple or 8 times the resolution of that area in particular. Stop this guy real quick and look at what we've got so far, and then I'll show you that fine scan or HD scanning option. While we're waiting for that, that'll be just a second. I'll go ahead and show you this. This is that project we did of the little Iron Man Lego set. Here is this is just the photos on their own. So if you weren't aware, this is something you can do with Artec Studio, is work with just photos to make scan data. As you can see, we turn off texture. The mesh is not the highest resolution thing, but considering this came from only photos this is actually iPhone photos too. It's really super cool that you can do this with just a phone or a nice camera with Artec Studio. And this is that AI photogrammetry process. So you brought in this case, it was 168 photos, and those I actually automatically extracted from a video. So instead of having to click, click, click photos, I just set this on a turntable, spun it around, and I can show you the video on its own. There it is. So set it up here on a turntable, spin it around, and then you drop that in Artec Studio, will automatically extract individual stills from that and drop them in here. You run it through 2 processes that do take a few minutes to crunch, but first thing it does is finds the position of all those photos. So that's what all these little indicators are showing, is that's where a photo was taken from. You can see that's exactly where it is. And then it can make a model from that. And so yeah, it's not the tightest geometry, especially compared to something like the point, but the fact that it came from just photos is super cool. And what happens as a consequence, you can texture that mesh, and that already makes it look better, but you still have some of that geometry in there. So I then came back and scanned this with the point, and so here's the result of that. That's just the point cloud. Here's after my fusion. And the cool thing here is when you scan with just photos, nothing's to scale. So this came in, it was like 20 times larger than the original, but Studio can handle that. It can automatically, through the alignment tool, the same thing you saw me do with the 2 bell housing scans a minute ago, it can go back and, actually, I'll show you. I'll pull up the history. We'll go back and see what that looks like. So if we go to Align tool, so last thing I did here was do that sharp fusion. If I turn on the scan in the background, that's how the small one is the point. So it's very accurate to size, to scale, real life, to that 20 micron accuracy. And the photos, it didn't have any reference of scale in there. You can actually have scale bars and things included in your photo set and get things a lot more close to real life. But the Align tool just handles that alignment. It was the same thing you saw me do earlier, where I just had to pick 3 common points between the 2. There's just a box I have to click that says allow scaling, and then it handles that for me. And it tied all these original pieces to it. So you can see all that data that came in to do all the photogrammetry. That's one of the parts I mentioned before. This is possible with other softwares, but it's complicated and you got to bounce back and forth between different softwares. This is the part that's just really, really easy. You bring all those photos in, align them like that, and I'll skip back to the end here. And then here's what that looks like with texture. So this is the best of both, the photos, color texture from the photos, and the geometry from the point here in one mesh. So something that there's other scanners very similar to this that you can only scan geometry with, and just something super powerful about the fact that this is in Artec Studio is you can take regular photos and apply color to these scans. Very cool. Here's our data from that scanning we just did. Got some of those threads in there. That's definitely, people ask all the time if 3D scanning is, different scanners are capable of reverse engineering or inspecting threads, and the answer is essentially, if they're larger and or external, then almost definitely yes. If they're internal and smaller than a quarter millimeter, probably not. But you can usually get a lot of really good information on like a threaded hole on something. You can always get a position. Usually those holes have a chamfer. You're definitely going to get at least a little bit into something. Our rule of thumb is about a quarter, sorry, 1 to 1, however wide the hole is and how deep it is, um, to how, uh, yeah, for how deep you can get. So a quarter inch hole, you can get about a quarter inch deep in that. And, but yeah, this is ideal. You definitely could reverse engineer those or do some sort of inspection on them. And then this guy, we've got some components on there that are resolving and some that aren't. We can always step that resolution up in somewhere and say, oh, refine that geometry and come in here and just pick an area that we want to crank the resolution up on with my lasso tool, hit scan. And then as soon as it sees me start to hit those points, you gotta tell it to use those targets too. It will allow me to up-res that scan basically. Actually, let's just run a separate example real quick. So you can start scanning without having to pre-scan the targets. It's usually not recommended, but it's so quick to scan your targets and there's a lot of benefit from it. Something you usually won't skip, but we'll do that here. I don't see any questions popping up yet. If anybody has them, feel free to drop them in there. And we'll save the last couple minutes for doing that Q&A if anything pops up. So I've established that area. Now you can see all I got to do is scan back over it, and Artec Studio is going to automatically handle deleting that existing data and filling it back in with this higher resolution. And since we're already close to the highest, I just doubled it, so I didn't go crank it all the way up. But you could start with like a 1 millimeter scan, something really coarse, not very fine, and do an 8 times, for example. So get something like a casting that's got large areas you want to fill in very quickly with the millimeter, but then you want to capture fine details in an area or two. You can do that with this, to a small area at this resolution, for example. Get the best of both. I have a question about how does this compare to the ScanTech SimScan and the ScanViewer program? If you are familiar with the SimScan, you'll notice this looks really similar. And the hardware is actually produced by the ScanTech and Artec. They just integrated it into their scanning software. It's similar. I mean, this specifically is it's very most similar to a SimScan 42 if you're used to using that. It's capable of all the same stuff. It's just a little different interface from the two. If you're not already familiar with Artec, that's probably what I'd say the biggest benefit of it is. If you're already familiar with Artec Studio and want to keep using that, this adds to like the Artec Studio ecosystem, just like anything else. There's also there's a lot of this stuff this can do. If you only need like heat maps, for example, like what you saw me do in Control X, that green and blue and red deviation map of the scan to the CAD, Artec Studio can do that. ScanViewer can also do that. There's some basic reverse engineering functionality here in Studio, and that stuff gets better every year. Artec Studio 20 is due to come out here in a few weeks, and That's something that Artec is, excuse me, really, really awesome about, is how much thought and time they put into their software. They're releasing major updates every year. Um, there's some cool stuff. I've heard a little bit about it, but I can't talk about it until it comes out in here in a couple weeks. But some exciting new things happening that affect both all the Artec scanners, including this one, and the photogrammetry process that you saw. I gave an example of earlier. But yeah, so to sum it up, I think this scanner specifically, you can do the same things in both. Artec Studio gives you a few bonus features that you couldn't do with the SimScan and ScanViewer. Uh, but yeah, overall, they're pretty good. We carry both, where we represent both Artec and Scantech, as well as a few other companies, Faro, and a couple others. This is the audio is getting softer. My apologies. Hopefully, well, we're almost finished. I'll try to speak up a little bit for the end, but um, thank you for pointing that out. So here's our HD data. It got a little bit finer details in those areas. Cool. Sweet. Unless anybody else has any other questions, I'll go ahead and wrap things up, I think. Um, if you liked anything you saw and you'd want to hear more about it, we've got a info at digitizedesigns.com. Feel free to shoot an email to that and you'll get in touch with us really quickly. We've also got a contact form on our website. You can fill that out and somebody will be in touch with you. If you want to see any of this again, we're going to have the recording uploaded to our YouTube channel here in the next, probably by tomorrow. And um, yeah. Oh, we got one more question. Do you find that when you increase the resolution, the final mesh is noisier? Um, Typically, yeah, higher resolutions just do mean there's going to be more noise. Um, that's kind of what you saw in that the circuit board. There's a little bit more surface noise. Usually, what that really mostly is the scanner's collecting both the position of all those points and their angle, like the normal direction, what angle they're facing. And usually most of the noise you're seeing is in that normal direction. So when you see that, we call it the orange peel effect when you crank resolution up, you'll see if you looked at it down the side, you'll see a very flat surface, but each of those individual points is a little bit the normal direction is a little bit noisy, and so that makes it look that way. But if you pulled it into a software and check the flatness, where it actually checks the heights of each of those points, like drags um, checks that it's a perfectly flat plane, usually you'll see it's very flat. But it's a natural thing with any structured light laser scanners. You crank the resolution all the way up, it is going to get noisier. That's also a consequence of the scanning settings to scan like dark or shiny or translucent things. Basically, the cameras have to look harder for the lasers, which means they look harder for everything, and they will see uh, data where there isn't more often. But there's a ton of tools. There's outlier removal, and the automatic filtering that happens when you stop a scan does a really good job of handling that. But that's a good question. And noise is kind of a symptom of all scanners are going to have it somewhat, and it's just knowing how to handle it, so what settings to do to avoid it, or uh, what what to do about the setup to try to prevent it, or what scanning situations you're expecting to see it in. But pretty much all of the softwares we carry have one way or another of handling it, and um, anything you get from us, we do our own training for, and that's kind of part of it. We don't. It's not a canned course delivered to you. We always try to tailor our training directly for your products. So we're not going to just cover every single button in Artec Studio. We're going to make sure we understand what you're doing, and we'll cover things that are important for you. If your scans are never going to be noisy because of the stuff that you're scanning, we wouldn't focus a lot on that. But if if you're handling glass things or dark plastic things, there's a lot of stuff to know about that to make sure noise doesn't get too bad. And we cover all of that to make sure you're getting the best the use out of the product we deliver to you. Cool. I think that's about it. Again, yeah, info at digitizedesigns.com. Should give us a shout out at that email if you'd like to get in touch with us for any reason. Got that contact form. This will be on YouTube, and we should have in about another month will be the next Scanner Spotlight webinar, and we'll see you then, hopefully. Everybody have a great day. Thanks.